Okay, division of polynomials, if we would like to know why and how it works. A really good strategy when you have no idea how something works is to do its opposite. So what we've been doing is we've been taking a polynomial, dividing it by a smaller polynomial and getting a smaller polynomial. The reverse of that would be what we've done here. This times this equals that. Now I won't do one with a remainder, so we'll do a nice easy one and it'll be a nice easy quadratic. So instead of trying to divide out a quadratic, let's first look at how we get a quadratic by multiplying other polynomials. Let's use x plus 2, x plus 3. If we expand that out, x squared plus 2x plus 3x plus 6. Gather like terms, x squared plus 5x plus 6. Now, if we were to turn this back into a polynomial division and say, well, what is x squared plus 5x plus 6 divided by x plus 2? The answer is quite obviously going to be x plus 3. If we were given this problem, we would work that out by factorizing the top and cancelling out the common factors and getting this answer. But actually, long division is another option. It's not a very good one, but doing long division where we can see what the answer is will help us understand how this long division of polynomials works. So we'll set this up as a long division. X plus 2 into x squared plus 5x plus 6. Now the thing that probably gets to you in the long division of polynomials is, why are we just putting this x into here? Why aren't we doing x plus 2 into here? And the reason is that it comes back to this 4 terms simplifying down into 3 and into what we know about binomial expansion or any polynomial expansion. We know that this first term in the polynomial came from the 2 first terms here, x and x. So that first term in my divisor and the first term in my quotient must multiply to give me this x squared. I don't need this plus 2 at all. X into x squared goes x times. And we know that that first term comes from those 2 multiplied together. So we can do that with impunity, knowing that mathematically we're quite correct. The 5x is a little bit of a tricky one because it's not the term that we got when we expanded. It's the combination of the 2 terms. If this had been written when they gave us our division as, please put x plus 2 into x squared plus 2x plus 3x plus 6, well, that would be great, because then we could go, well, how many times does x plus 2 go into x squared plus 2x? It goes in x times. And how many times does x plus 2 go into 3x plus 6? It goes in 3 times. Oh, look, we've got our answer. X plus 2 goes into this x plus 3 times. But we don't have that. We've got the combined middle term. So, once we've got the fact that our x multiplied by an x to give us x squared, we can then say, let's multiply that back, because I know that this x must have been multiplied by everything in that first bracket to give me a part of this 5x. So let's find out by multiplying back how much of that 5x it gave us. X times x plus 2 is x squared plus 2x. Bingo. this x that we just found, multiplied by this 2 that we know we've got, gave us 2x out of this 5x. We subtract to find out what we've got left. These cancel. 3x, bring that down. Now I've got to deal with the 3x plus 6 that's left over. Now because I set this up without a remainder, we could do, well, x plus 2 goes into 3x plus 6 3 times. But in case there's a remainder, we'll just do that this way. Because we can see now that this form of polynomial division works. So we're saying, all right then, this x that we know we have here, how many times does it go into this 3x that we know wasn't dealt with from that one? It's from here. Obviously it goes in 3 times. Now we check that 3, we know that has to have been multiplied by this bit and this bit. See what we get when I do that 3 multiplied by x plus 2. I get 3x plus 6, which says, hey, there's no remainder. There's nothing out of this 6 that we needed to be dealing with separately. So we subtract, we get 0, and our answer is x plus 3, which we knew. So that's why our division of polynomials, works. That we're using the expansion of polynomials to understand how we can divide back into it to get an answer.